In 7.1 notes, we're moving on to trigonometry, which is actually the study of triangles. So we're looking at right triangle trigonometry definitions. Let's do a little review. First, in our picture, remember angles are labeled with capital letters, sides are labeled with lowercase letters, and they correspond in the following way. Remember, across from angle A would be side lowercase a, across from B would be lowercase b, and across from angle C would be lowercase c. Okay, remember we know that the side across from the right angle is called the hypotenuse. Okay, because we're going to be putting that in our definitions. And we know the other two sides are legs. Okay. All right. So anyway, if you just think about the words opposite and adjacent, if you've not heard those before, at least not adjacent, maybe. Opposite, think about if you're sitting opposite of somebody at the table, they're across from you. So the opposite side is the leg across from an angle. But the key there is that it's a leg. Okay, it can't be the hypotenuse. An adjacent side, if you're adjacent to somebody, you are sitting next to them. So an adjacent side is a leg next to an angle. Again, key is that it's a leg. It can't be the hypotenuse because the hypotenuse stands by itself. Remember, the hypotenuse is across from the 90 degrees. Across from 90 degrees, and it is also the longest side. Okay, so we'll do a little bit of color coding here. This is all about the angle's perspective. So from angle A, okay, so if you're standing here at angle A, then the opposite side is lowercase a. The adjacent side, remember, the only leg that it's next to B and C. But C is the hypotenuse. So the only leg that it's next to is B, lowercase b, and the hypotenuse is always side C. Okay, so now, change our perspective, we'll change colors. So from angle B's perspective, all right, so now you're standing here at angle B. Well, the opposite side now, across from angle B, is the lowercase b that we labeled earlier. Okay, so the lowercase b. The adjacent side, if you're standing at B, you've got, it's between A and C, but C is the hypotenuse. So the adjacent side is lowercase a, and the hypotenuse, like we said, is always C. Now, from angle C, okay, from angle C, where the right angle is, there's no opposite or adjacent side, right? Because if you were standing here, think about this. If you said adjacent side, I wouldn't have a clue if you wanted me to say A or B. Okay, so it doesn't make sense to do this from the right angle. Plus, the opposite side would be the hypotenuse. And we already clearly stated that the opposite side had to be a leg. Okay, so let's put all of that kind of down here. So from angle C, we'll say there is no opposite or adjacent side. There's really only the hypotenuse. And kind of think of them as like names, right? You wouldn't want somebody to call you a different name than was given to you, right? You want to be called your given name. Think of it as hypotenuse is going to be offended if you call it opposite or adjacent, okay? Because that would make it a leg, and it's not a leg, it's a hypotenuse. So we will just make the note here that don't use the right angle. Okay, don't use the right angle when you're talking about angle perspectives and trying to figure out opposite and adjacent. Okay? All right, so next. trigonometry ratios. Sorry, that's a hard word to say. Trigonometry ratios. So anyway, if you are thinking about ratios, remember ratios are fractions. Okay, so when we look at this, the sign, guys, here's how they're actually spelled. Okay, these are the ones where we said you've got to have these keys, however, on your calculator. On your calculator, you'll see sin, cos, and tan. So it's always sine of an angle, cosine of an angle, and tangent of an angle. And by definition, guys, sine is opposite divided by, okay, so I'll use this as my fraction bar, hypotenuse. So we're always using the words opposite, hypotenuse, and adjacent, okay, like we just did on the previous slide. So there's this mnemonic, right? Okay, you've probably heard people, brothers, sisters, other peers say SOHCAHTOA. So what this is telling you guys over here, SOH, is trying to help you remember that sine, right, the S, sine, is opposite over hypotenuse. That's what the SOH is. Okay, and then same thing over here, right? CAH is going to try to help you remember that the C for cosine is adjacent, which I'm just going to abbreviate now, over hypotenuse. Right? So that's the cosine, the C, the A, and the H, adjacent over hypotenuse. And last, TOA in SOHCAHTOA. It's supposed to help you remember that tangent is opposite over adjacent. Okay, so again, the T in the tangent, TOA, opposite and adjacent. Okay, that's what we're trying to help you remember there with that SOHCAHTOA. And you come up with any mnemonic you want. Now, as far as SOHCAHTOA, that's very helpful. The problem becomes if people can't remember how to spell it, right? Like ka, sometimes people don't spell C-A-H. So come up with something, guys. Come up with a 9-word phrase, okay, for these different letters. There's 9 of those there. Come up with a phrase or something just crazy enough to help you remember it. Okay, now I just stole this from this next page from another teacher. I think they got some of these off the internet, some from their students. They just came up with things. So if you want to use any of these, like some old horse caught another horse taking oats, come up with something crazy enough that's going to help you remember that SOHCAHTOA is spelled SOHCAHTOA. Okay, and you can read through some of those on your own or come up with some of those phrases that work for you. All right, so here we go. Now, if you're looking at these problems, the first thing I hope is going to be apparent is that you should always have all 3 sides of the triangle. This should be review, right? Number 1, notice we already have all 3 sides. It should be review that it's an 8, 15, 17 right triangle, though. If you did not have one of them, you should be able to get the other. So when you're saying to find sine of A, then remember that means be careful, stand at A. So from A's perspective, sine being opposite over hypotenuse, well, opposite of A is 15, and the hypotenuse is 17. And your job, okay, remember the answer blank is the answer blank. Please don't use it as your fraction bar. Your job is to completely simplify. So always reduce, rationalize if we've got roots, any of that kind of stuff. If it doesn't reduce, you guys can just leave that. If there's work on the line, I need you to go ahead and box your answer. Okay, so here we go. 15 17ths does not reduce, so we're done. Cosine of A says standing at A, again. Okay, then the adjacent, because ka is cosine, A adjacent over hypotenuse. Cosine is the adjacent side, which isn't the hypotenuse, so 8 over the hypotenuse of 17. 8 17ths does not reduce, and therefore that is your answer. Okay, tangent of A. Again, standing at A, the opposite over adjacent. Opposite is 15, adjacent is 8. 15 eighths does not reduce. Remember, that's an improper fraction, fully reduced. That's what we expect. Okay, so now what's changing? You got to read these carefully. The next thing says sine of B. That means change your perspective. So stand at B. Okay. Why don't you turn it off for a minute and try those last three. Find the sine of B, cosine of B, and tangent of B. And come back and join me. Okay, let's see how it went. So from B's perspective, sine is opposite over hypotenuse. So opposite is 8, hypotenuse is 17. 8/17 does not reduce. That's your final answer. Cosine is adjacent over hypotenuse. So from B, adjacent is 15, hypotenuse is 17. It does not reduce. 15/17 is your answer. Tangent is opposite over adjacent. So from B, opposite is 8, adjacent is 15. 8/15 does not reduce. You are finished. Okay, so remember, the difference is about where you're standing. It's from which angle's perspective you're talking about, and it's never from the right angle. All right, number 2. Let's do our little review stuff first. Okay, so I'm missing a side. If I'm missing one side, I know that I'm supposed to first see if it's a 30, 60, 90, or 45, 45, 90. There's no markings that tell me that. So I'm going to go on to reducing, then triples, then Pythagorean theorem. Okay, so here's our work. Let's reduce 8 and 10 by 2. That will give us 5 and 4. They do not reduce any further, so I should be asking myself, are they a triple? And we should agree that that is a triple, 3, 4, 5. That means I automatically know this side is 3. To undo what I did at the start, I divided by 2, so I need to multiply by 2, and therefore the length of this side is 6. Now, before you start, I highly, highly suggest that you circle all of the bigger numbers or all of the smaller numbers. We'll talk about that as we work. In other words, 8 goes with 10, and it also goes with, on this side, the 6, right? Those are the bigger numbers. The reduced numbers were the 3, the 4, and the 5. Okay, but it's very easy to just look at that if you don't circle something and put maybe like an 8 with a 3. Okay, here's what I mean by that. Sine of n. Remember, it's from n's perspective. If you stand here, sine is opposite over hypotenuse. So opposite is 6, hypotenuse is 10. I'm using the big numbers on purpose. Remember, we said your work is to always give me the fully reduced answer. 6/10 reduces, right? Both of them reduce by 2. Final answer is 3/5. Here's what I was saying. If you do work on the line, I need you to go ahead and box your final answer for me. That's what you want me to grade. Okay. Now cosine of n. From n's perspective, using the red circled numbers, cosine is adjacent over hypotenuse, so 8 over 10, which reduces to 4 over 5. Box that. That's what you want me to grade. Now please notice, could we have saved ourselves some reducing on these if we had used, maybe I'll underline them now, the 4, the 5, and the 3. Think about that. If you go back and do the sine of n again, and you use the underlined green ones, wouldn't the opposite over the hypotenuse had gone straight to the 3/5? Okay, but you've got a problem if you accidentally put like the 3 with the 10, right? Because that's not the same. So you've got to be super careful about that. Okay? All right. I'm just going to keep using the bigger numbers because I'm fine with reducing. All right. Sine of P. Ooh, notice we've changed perspective, right? We've got to change where we're standing. If you go stand at P now, opposite over hypotenuse now is 8 over 10, which is 4/5. Box it. There's your final answer. And last but not least, tangent of P. Tangent is opposite over adjacent. So 8 over 6 equals 4/3. Box your final answer. Okay? All right, next one. Missing sides means I need to find the sides first, right? So I see that it is a 30, 60, 90 to begin with. That's the first thing I'm noticing. And therefore, I know the short leg across from 30 is 5. To get the hypotenuse, I need to multiply by 2 to get 10. If you've got the short leg and you need the long leg, you need to get longer. Therefore, you need to multiply by root 3. So this should be 5√3. Right, that stuff has to be down pat. That's got to be second nature to you, okay, to be able to get this stuff right. All right, let's start. From t's perspective, cosine of t. Cosine is adjacent over hypotenuse. So I'm going to have 5√3 over 10. You've got to reduce. The 5 over the 10 reduces to a half. Remember, we don't write ones in front of roots or variables. So this should just be √3 over 2. Final answer, box it. Okay. Why don't you turn off the video and try the next 3. Try the next 3. Okay, let's go through it. Sine of t. Hopefully you were thinking opposite over hypotenuse. So 5 over 10 reduces to 1/2. Okay. There we go. Tangent of s. So notice you've changed where you're standing. Okay. I won't put that dot anymore. I'll just let you look at where you're standing. From s, tangent being opposite over adjacent. Opposite of s is 5√3, and adjacent is 5. The 5's reduce, right? They would be 1 times √3, which is just √3. There's your final answer. Sine of s. Sine of s. Opposite over hypotenuse. So opposite of s is 5√3. Hypotenuse is 10. Again, the 5/10 reduces to a half. You don't write the 1 in front, so you would just have √3 over 2. Okay, let's do this last one together. Tangent of t. Tangent of t. So tangent is opposite over adjacent. All right. So I'm going to do some work down here so I have room. So here's the opposite is 5. The adjacent is 5√3. And let's do this a couple of different ways. So remember, we can't leave roots in the denominator, right? So we have to rationalize. That means I need to multiply by √3 over √3. Now there's a couple different ways we can go with this. Let's just go ahead and do it this way. Okay. So if we multiply straight across, we'd have 5√3 on top. The bottom, be careful. √3 times √3 is 3 times 5 is 15. Okay, and therefore, you now need to reduce the fraction. 5/15 turns into 1/3. Remember, we don't put the 1 in front, so you would just have the √3 over 3. All right, I'll go ahead and put that answer up here. There's √3 over 3. I wouldn't have had room to do that on the line. Now, you could have thought about this, guys. Think, try to make your life easy. All right, if you're going to do 5 over 5√3, couldn't we have reduced the 5's first? 5 over 5 is 1, right? Over the √3 is all that would be in the denominator. Well, now you rationalize by √3 over √3, And when you multiply straight across, you get root 3 over root 3 times root 3 is 3. You get the same answer, but it was just already reduced. So sometimes it's a little bit easier to actually reduce first. Okay, so think about that. Whatever is going to be easier for you. Either way, there's your work for that. Okay? All right, so really get down that SOHCAHTOA, practice with these, make sure you're fully reducing those fractions. Okay, come up with some sort of mnemonic so you can remember how to spell SOHCAHTOA. That's going to be the key. Good luck.